In this video, I want to solve the differential equation x double prime plus 9x equals f of t, where x of 0 and x prime of 0 are 0. This is again going to be done with Duhamel's method. Duhamel's method is really, or Duhamel's principle is really a principle about how to solve partial differential equations that come up using the Fourier transform. Again, we're going to use the Laplace transform to solve ordinary differential equations like we've been doing so far. So what we're going to do is, since this is an arbitrary function, little f, we're going to have a little f function in our answer somewhere. And so we're going to start by taking the transform. We know that if we take the transform of x double prime, we're going to end up with s squared, capital X of s, minus s, x of 0, minus x prime of 0. If we take the transform of 9x, it's going to be 9, capital X. And the transform of little f is going to be capital F. And by assumption, our initial values, x of 0 and x prime of 0, are both 0. So those will cancel. And it turns out that we're going to have capital X of s is going to be 1 over s squared plus 9 times capital F. And so we have a product in our answer. So our transform, capital X, is equal to a product. And if we take the inverse, Laplace transform, in other words, to get little x, this will be the inverse Laplace transform of 1 over s squared plus 9 times capital F. And so we know that the inverse Laplace transform of a product will be a convolution. So little x of t is going to be the inverse of 1 over s squared plus 9 convolved with the inverse Laplace transform of capital F. And so that tells us that our solution, little x, is going to be the inverse Laplace transform of 1 over s squared plus 9. This is a 9. And that's going to be, let's see, we'd have to put a 3 up top. So we'd have to put a 3 and then put a 1/3 out front. So that would make this 1/3 sine of 3t. And then we convolve that with the inverse Laplace transform of capital F as little f. And this, by definition, means that, by definition of the convolution, this is going to be the integral of 1/3 sine of 3y f of t minus y dy. And there we are.